So to start off the problems, this would be a non-calculator portion part of your test. But all it wants you to do is say that you know that k is 3, so we'll plug 3 in, and then go ahead and solve the equation for k. So we can multiply both sides of the equation by 3. So I have x minus 1 is equal to 9, and I will solve by adding 1 to both sides. So then x is equal to 10. The second problem deals with imaginary numbers, and while we didn't look at imaginary number problems like this in our last unit, we do know how to add like terms. And when you're adding imaginary numbers, we treat them just like we would any number that has an x variable with it. So we can go ahead and combine like terms. So my like terms would be my 7 and my negative 8, and my positive 3i and positive 9i. So if I add those two together, I will get negative 1 plus 12i, and that would be answer A. Both of these problems are solving systems of equations. Notice that they are on the non-calculator portion. The tricky part about the first one here is that y is not lined up with y. So before we can even begin solving by system of equations, we have to go ahead and rewrite it. So I'm going to have 3x plus 4y equals negative 23, and I will have negative x plus 2y equals negative 19. I can then go ahead and add up these equations. I'm going to go ahead and use elimination. But before I can do elimination, I need to make these two look the same. And the easiest way to do this would be to multiply the bottom equation by 3 so that I have all of my x's looking the same but with opposite signs. So this top equation will stay the same, and the bottom equation is going to be negative 3x plus 6y equals negative 57. We can cross out our x's, and then when I add this up, I have 10y equals negative 80, and I'll divide both sides by 10. When I do, I get that y is equal to negative 8. This is the SAT. It's timed. There's no retakes. There's no chance to go in and finish it later. So stop here and take a look. There is only one answer option where I have y is equal to negative 8. So it doesn't even matter what I would get for my x values because my y value is going to be different. So I want to just make sure that I stop and check my answers because I can stop now and I don't need to keep going. For the second problem, I'm going to go ahead and multiply one of my equations by negative 1. When I do that, that will allow me to have opposite signs on my x. So I'll have negative x plus minus y equals positive 9. And then the second equation will just stay the same. I can go ahead and add these up again together, and I will get y equals negative 16. It asks me for the x value though, so I plug it into whatever looks easiest. I believe that the top equation looks easiest, so I will plug in my negative 16, and I will need to solve that by adding 16 to both sides. So I will get x equals 7. And notice that this one there's no multiple choice, and that's because this question is not going to be one of the questions you would have multiple choice, which you'd actually bubble in your answer. And once again, we will practice this together when we come back from spring break. Equals. For the next problem, I need to find the value of g of negative 4. So when I say g of 4 equals 8, all that means is if I plug x in, everywhere I see x, if I put 4, then this side of my equation would equal 8. So I can write it out that way. I can write it out 8 equals a times 4 squared plus 24. So that means that I will have 16a plus 24, and then I have a two-step equation that I need to solve. So negative 16 equals 16a, divide both sides by 16, so I get negative 1 is equal to a. Now I want to find the value of negative 4. So all I would do then is take this equation again, and if I know that I'm plugging in negative 4, so g of negative 4, I found that a was negative 1, plugging in negative 4, and then add 24. So equals negative 1 times 16 plus 24. Negative 16 plus 24 means that my answer would be positive 8. On number 16, this is actually a solving by square roots problem. You just took a test that could have had this question on it. The difference is it has this part where it says if t is greater than 0. So we know that when we solve by square roots, our goal is to get the squared term by itself. And then I can take the square root. Because I took the square root, I have plus minus. So I get t equals plus minus 2. So I have a positive 2 and a negative 2. Which one of those is greater than 0? Positive 2. So that would be my answer to number 16. The next problem is asking me if I had a coordinate plane and it's going through the origin, from the origin, so from right here, I am going up 1 over 7. So I go up 1 over 7. So over 7 would be an x value of 7 and a y value of 1. But that's not one of my options. So now I need to do it again. So I'm going to go up 1 over 7. And that's going to be, if I went up another 1, so from 1 more is 2. And then over 7 again, that's 14. So this answer then would be D. The reason this one is tricky is because in our brain, when we are talking about slope and coordinates, they go in two different orders. When I'm talking about slope, it's rise over run, so it's y over x. But when I talk about coordinates, I'm graphing x and then y. That's what makes this one tricky. So there are a lot of questions like this where once it's explained, it makes sense. But if you don't stop to think about what they're asking, it can lead to some tricky issues. The next problem says 2a equals the square root of 2x. Now we haven't gotten to these problems yet, but I am confident this is one you guys will understand based off of the unit we just completed. All I have done so far is I have taken what I know that a equals and I have plugged it into my equation. At this point, I can go ahead and undo this square root by squaring both sides. We're going to square the 2. We're going to square the 5. So that would be 25. And then remember, if we square a square root, it just stays. So it's just going to be 2. So we lose the square root, but the number itself stays. And then this side, same thing, it's just going to be 2x. So then I have 4 times 50 equals 2x. So 200 equals 2x. There are other ways you could have gotten to that 200 as well, and you still could have ended up with the same answer. So x equals 100. This next problem is a little bit of geometry. And so this problem is talking about parallel lines cut by a transversal. So I think for this one, the easiest way to start thinking about this one is to make clear which lines we want to look at. So these are the lines I'm going to look at as being parallel. And then this is going to be the space in between them. And they're going to be cut by this transversal. So notice line T, I'm not even going to really use that. I can use that to recognize that I have this angle here is a corresponding angle with angle 1. So it's the same measure as angle 1. But outside of that, then I'm just going to think about this part of my shape. I know that angle 1 and what I'm going to write as the question mark angle, these two are linear pairs. So a linear pair is what we would call supplementary, and that's where I have a plus b equals 180. So I can say x plus, I know that the measure of angle 1 is 35, equals 180. Subtract 35 on both sides, and we have x is equal to 145. Then the relationship between my question mark and angle 2 is that these are corresponding, and corresponding angles are congruent, and angles that are congruent are going to be the same. So the answer to this one will end up being 145. Let's say you don't remember any of that. Look at the picture. The picture looks like angle 1 is a very similar size to all of my other tiny angles. So it looks like this angle, this angle, this angle, all these little ones, it looks like are the same. In the same way, it looks like all of the larger angles, like angle 2, are the same. Knowing that these are parallel lines, if you can just remember that some angles were congruent and some angles were supplementary, and that supplementary meant that I was adding up to equal 180, you can reason through this without even knowing what the vocabulary words are, that it's either going to be a congruent angle or it's going to be an angle that sums to 180. And that's another way that you can reason through this problem. If you looked at my workout answer key, there's also a different way of thinking about it. There were lots of ways to get to this answer. The next problem says that if I have this equation, y equals kx, and I know that I have y is equal to 24, and x is equal to 6, I can figure out what that constant is. So all that means is that no matter what I do to this problem, I'm always going to end up with the same k value. So I have y equals kx. I have my 4 is what I found by solving the equation. So now that all we're asking is, what happens when x is equal to 5? So do the same equation, but instead of plugging in the original numbers, I'm going to find y. I'm going to use the 4 from the first time, and I'm going to plug in that 5. So 4 times 5, that's 20. That's another one that we don't teach stuff like this, but it's just Algebra 1. It's a different way of looking at the kinds of problems that you might need to do. And so that's one way that we can solve this one. There are a couple other ways you could do it, but I think this is the one that makes the most sense. Most SAT problems are going to be multi-step kind of problems. And so thinking through things in pieces is going to be really important. The next one, I have to find something that has a negative association, and they want it to be a strong negative association. So when we're dealing with data points, if we're talking about strong, that means that our numbers are close together. So lots of dots, really close together. If it's weak, that means that they're far apart. So we might be looking at something more like this. If it is a positive association, that means that my graph's going to go up. And if it's negative, that means it's going to go down, just like we would think for slope. So which one of these has things that are close together and goes down? That would be answer choice D. The next problem says that if I have n minus 1 plus 1 and it's equal to 0, can I find a value where that's a true statement? And so I'm going to start by getting my absolute value on the other side of the graph. Now remember, absolute value says that I take any number. If it's positive, it stays positive. If it's negative, it becomes positive, because it's not actually counting the number, it's counting the value from the distance from 0 to that number. And so if I want this to equal a -1, which is what my equation solving it says it has to be, there is no way that I can put things into an absolute value bars and I can have it come out with a negative answer. This next problem is a little tricky. The way that you read the graph is deceptive. This graph is saying that there are 2 apples that have 3 seeds in them. So if I'm trying to find the mean or the average, that means I'm adding all my numbers up and I'm dividing by the number of things I added up. So I actually have 2 apples that are 3. Another way we could write that might look a little bit more like we're used to with average is just 3 plus 3. The next one says that I have 4 apples that have 5 seeds. So I'm going to add up 4 5s. The next one says I have 1 apple that has 6 seeds, 2 apples that have 7 seeds, and 3 apples that have 9 seeds. If I add up all of those numbers together, that is 12 numbers that I am adding together. So you can put that in your calculator. Remember, this is the calculator portion. And when you put that in your calculator, it's going to give you a 6.08. So the closest answer I've got is 6. Do expect decimals, do expect fractions, and do expect answers that are slightly different than what you may have expected. 6.08 is not exactly 6, but for the SAT, that's the kind of thing they're looking for, because it asks for which is the closest. So keywords like that can make this a little tricky. All right, so a food truck is selling salads and they are selling drinks. So I'm going to use X for my salads and I'm going to use Y for my drinks. So if I go ahead and I set up an equation, I know that they sold 209 total in the day. I don't know anything about which is which or how much of each, but I know that together, if I add up all the salads and I add up all the drinks, that equals 209 things sold for the day. I have $6.50 for a salad and $2 for a drink is going to equal $836.50. This is a system of equations problem, but you have to set it up. I'm going to go ahead and multiply this top equation by -2, and that's going to give me -2x minus 2y equals -418. I then will have 6.5x plus 2y equals 836.5. Add those up, it's going to eliminate the y's, so I have 4.5x equals 418.5. Now remember, my x is solving for the number of salads, so all I have to do is then solve this one-step equation, and that's going to give me 93, so that is the number of salads that were sold in the day. I want to talk about the equation of a circle now. So the equation of a circle is x minus h squared plus y minus k squared equals r squared. My center is at 0 and 4. So when I plug in my center, I'm plugging that in for h and k. And if you remember from geometry, if you have x minus 0 in a circle equation, that's just the same as written as x squared plus y minus 4 squared equals r squared. Now the tricky part here is I need to figure out what the distance is between this point and this point. So that's where we go back to the distance formula. So the distance formula is the distance between my x values and my y values. So I'm getting this from, this was my x2, y2, and my x1, y1. I go ahead and do that math, so I end up with -4/3 squared plus -1 squared. If I go ahead and put those in my calculator, I'm left with 16/9 plus 1. Add those together, and your calculator will tell you 25/9. If I take that, don't try and simplify it, but if I take that and I plug it into r squared, that's going to give me x squared plus y minus 4 squared equals the square root of 25/9 squared. We know that if I have the square root and I square it, it goes away. So that answer is x squared plus y minus 4 squared equals just 25/9, because both the squared and the square root go away, which is going to give me answer choice A. For problem B, this is kind of a word problem for solving quadratics. So we're talking about when will the ball hit the ground. So my equation, h is height and t is time. So if it's hitting the ground, that means that the height is 0. I'm always measuring the height of something from the ground. If you go to the doctor's office, you stand on the ground, they measure your height. That's going to be h is equal to 0. So if I take this equation and I say 0 equals -4.9 t squared plus 25t, there are a couple ways you could solve it. If you remember the quadratic formula, you could use the quadratic formula. You could also think about the fact that there's 2 t's inside of t squared. And so we could rewrite this as t times -4.9t plus 25. So all that I've done here is factored out one of those t's from each of my numbers, the -4.9t squared and the 25t, and I've just put it outside. At this point it's factored, so I can take this factor and set it equal to 0, and this factor and set it equal to 0. So t equals 0, and negative 4.9t plus 25 equals 0. This one I need to go ahead and solve because I don't see t equals 0 as an option. So that means that I should find my answer when I go ahead and I solve this. So negative 4.9t equals negative 25. Divide by negative 4.9. And I end up with t is equal to 5.1, which is approximately 5. Remember to watch out for those keywords and don't be bothered if your answer is close but not quite there for one of those problems. All right, the next one is talking about solving systems of equations. And it's including inequalities. So my slope here is 2, my y-intercept is 1. So if I just kind of sketch this, y-intercept at 1, go up 2 over 1, my line is going to look something like this. Now, in Algebra 1, you graphed inequalities. Those inequalities we can shade to find all the possible answers because it's saying that y is greater than any of those answers. So I'm shading above that line where y is greater. And I'm going to do the same thing with my other equation. So for the other equation, I have that my slope is 1/2, that my y-intercept is negative 1. And so I can go ahead and graph negative 1, and I go up 1 and over 2. It's not greater than or equal to, it's just greater than, so I put a dotted line, which isn't going to make a difference for your problem if you don't remember that. And then it says greater than again, so I shade everything above. So any of my answer to this problem is any coordinate that is located inside of this space where both colors overlap. And I've kind of boxed that in yellow. So anything inside of that yellow space would be something that would be an answer. So it's got parts in 1, in 2, and in 3, but there are none of those answers in quadrant 4. And that's why quadrant 4 is the answer. Even though the red equation is partially there, the blue one is not. So that's not going to work. Number 30 almost tricked me. When I looked at this, I wanted to look at this and say that this is negative 3, this is 5. I could put it in intercept form, and I could call it A. The problem with that is it's not asking for intercept form. It wants to know which of the coordinates of vertex A can be identified. Well, here's vertex A. This is 1, negative 16. It looks like it could be negative 15, but it's just a little bit further past. So that coordinate is 1, negative 16. The form for A, that does not tell me anything about what the coordinates would be of the vertex. So I need to put this into vertex form. This is one of our forms from first semester. So I have A times x minus h squared plus k. Let's see what happens. Notice that none of my answers down here really have a number in front where A would go. So let's just assume A is 1. So if I'm plugging in my vertex, I switch the sign of h. Keep k the same. So the one that says x minus 1 squared minus 16, that would be option D, and that will be my answer. All right, last two for today. I am first looking at, this is just a word problem. Television station sells time slots for programs in 30 minutes intervals. It operates 24 hours every day. So how many 30-minute slots are in 24 hours? Well, in 1 hour, there are 2 30-minute slots. So if I multiply 1 times 2, there's 2 of them, so 230. So I can multiply 24 hours times 2, and in 24 hours, I have 48 half-hour slots. Now, I want to know in 1 day I can do this. I'm asking about Tuesday and Wednesday. It doesn't matter what days I'm saying. I'm just saying 2 days. So 48 plus 48 gives me 96 slots. Very last problem for today is talking about the cylinder. This problem requires you to know the volume of a cylinder or to be able to look at your formula. So the formula is volume equals pi r squared h. You don't need to know that, it's on the formula sheet. The radius is the distance from the center of a circle to the outside. I don't know that, it's not on my picture. But I do know the height, and the height is 8. So my formula right now, I know volume equals pi r squared times 8. It's telling me in the directions that the volume of this silo is 72 pi. So I can go ahead and take that equation. I'm going to plug in 72 pi instead of plugging in my volume. So all I've done is kept this equation the same, but instead of putting volume, I put what the problem told me that I got for volume, and that would be 72 pi. Notice there's pi on both sides. We can go ahead and divide by pi on both sides and watch it disappear. So 72 equals r squared times 8. Divide both sides by 8. 72 divided by 8 is 9. 9 equals r squared. I can take the square root of both sides, and I get r squared equals 3. Now it's not asking, not r squared, just r. It's not asking for the radius though, it's asking for the diameter. So if this part is the radius, the whole length is the diameter. So I would add 3 plus 3 to get 6. And that is the answer for the diameter. Once again, multi-step, but the bite-sized pieces are not particularly hard. The difficult part is putting it all together.